everyone. In this mini lecture, we're going to look at some basic differentiation formulas and some properties that you should know to start out with. All right, so let's go ahead and take a look at some properties first. So first property that's important, let's say we have f of x plus or minus g of x. So f of x plus or minus g of x. And here, let's say we were asked to take the derivative. So I'll just say f of x plus or minus g of x, put those in brackets and say prime, right? That's telling us to take the derivative or find the derivative. So basically, to find the derivative, the property says that we can take f of x, f prime of x, I should say, and then add or subtract whatever the operation is, and take g prime of x. So in other words, if you want to differentiate a sum or a difference, that's what the plus or minus means here. All we have to do is differentiate the individual functions. The f of x, take its derivative, and the g of x, take its derivative. Then just put them back with the signs that correspond, the plus or the minus. Okay, in this next property, it'll look something like this. Let's say we have some constant that's being multiplied times our function. And then we're asked, or we're told, hey, let's go ahead and take the derivative. So if we're told to take the derivative, they'll say this constant times this function f of x, and then we'll just say take the derivative, so that's c times f of x prime. Okay, so what we can do here is go ahead and then write c times f prime of x, right? So we have that c as a constant. We can move it out some and then take the derivative of the function, right? So we can factor a multiplicative constant out of a derivative if we need to. And then just take the derivative of that function, and then we can multiply them back together. Okay, so next come two basic formulas that they give us for differentiation. The first one says that if f of x is equal to c, right? So if our if our function is equal to a constant, then here we can say, let's find f prime of x. So take the derivative of that function, and we're saying it is a constant. Well, the derivative of any constant is going to be 0. 0. The derivative of a constant is always 0. All right, so the next formula, very important one, if f of x is equal to x to the n power, right? If f of x is equal to x to the n power, then our formula says that to find the derivative, f prime of x, what we do in this situation is take that exponent and it goes in front of our function, and then we subtract 1 from the exponent. So this is called the power rule. It's usually called the power rule. So all we're doing here is bringing the original exponent down in front and multiplying, and then subtracting 1 from the original exponent. Okay, so in this first example, if you take a look at it, we have 4 terms. Terms are separated by plus or minus sign. So we have the sum and a difference for the 4 terms. So we're going to differentiate each of the terms using one of the properties that we went over, right? that property was that sum difference property. So what we'll do is we're going to take the derivative of each term. So in taking the derivative of the first term, 15x to the 100, we're going to have 15. We'll pull that 15 out. The 15 comes out, and then we're going to say, okay, take the exponent of the 100, and we're multiplying that, put that in front of the x, and then we're going to subtract 1 from the 100. That gives us 15 times 100 x to the 99th power. All right, so same situation for that second term, right? We have negative 3 x to the 12th power. Well, we can pull out the 3. It's a constant. And then we can just say, okay, let's take the derivative of just the x to the 12th power. So we take the 12, put it in front of the x, and subtract 1 from 12 to make 11. All right, and then same situation can occur for the 5x. We can pull the 5 out, and then the exponent for the x is actually a 1, right? So if you put a 1 in front of the x and then take 1 from the exponent of 1, you get 0, x to the 0 power. So anything to the 0 power is 1, so you're just saying 5 times 1, which is just 5. And then we go back to that derivative of a constant rule, right? That one said that it's 0. The derivative of a constant is 0. All right, so now we just clean it up a little bit and do some multiplication. The 15 times 100, we get 1500 x to the 99th power. The 3 times the 12, and it's a negative 3, so let me get your signs. So that'll be 36x to the 11th power, right, to the 11th power. And then we can just bring down the 5, and of course no need to write the 0. Okay, so then we can say, okay, that we have now found the derivative of this function. So I'll say f prime of x is equal to 1500x to the 99th power minus 36x to the 11th power plus 5. So in our next example, we have f of x, our function is equal to 2x to the 6th power plus 7x to the negative 6th power. So looks like we have only 2 terms here. 1, 2, 2 terms. So with that, we would do what we did in the last problem, use that sum difference property, right? So we're taking the derivative of each term separately. So we're taking the derivative of 2x to the 6th, and then the derivative of 7x to the negative 6th. Just a little bit different with the notation that I'm using here, but it means the same thing. I could just use f prime of x if I wanted to, but here I'm just going to go with the Leibniz notation as well. So in taking the derivative, we said that the 2 can come on the outside, right? Because the 2 is a constant, and then we take the derivative of x to the 6th. Same thing here with the 7. The 7 is a constant, so we can use that rule, that constant multiple rule, and it comes on the outside, and then we'll just be taking the derivative of x to the negative 6th. And for this one, x to the 6th power, it looks like we're just going to use the power rule, right? The power rule says to go ahead and bring that out to the front of the variable and subtract 1 from the exponent to make 5. And looks like the same thing for this one. The power rule says to go ahead and bring the negative 6 down in front of the variable and then subtract 1. Subtracting 1, doing a minus 1 from a minus 6 will get us minus 7, right? And then we just clean it up a little bit. We just multiply, then we get 12x to the 5th, and 7 times negative 6 will be a negative 42, and this is x to the negative 7th. All right, so we could say that, okay, f prime of x, the derivative is 12x to the 5th minus 42x to the negative 7th power. Okay, in our next example, we have y is equal to 8x to the third minus 1/3 x to the negative 5th plus x minus 23. So we're asked to find the derivative. So I'm going to look for y prime. Y prime. So we have 4 terms here, 1, 2, 3, 4. I need to use that sum difference property. So in using that, that means take the derivative of each term separately. So I have 8 that I can pull out, right, because it's the constant. And then if I take the derivative of x to the third, I pull out the 3 in front of the x and then subtract 1 from the 3 in the exponent. So that becomes a 2. Here in the middle, right, that negative 1/3 is my constant. So I pull that out and I take the derivative of x to the negative 5th. So negative 5 is what I'm multiplying the 1/3 by, and I put it in front of my x and then subtract 1. When you subtract 1 from a negative 5, you get negative 6. So just be careful with the signs of the exponents. And then when we get to that third term, the derivative of x. So x is like x to the first power. You can think of it like that, right? We just don't write the 1 in the exponent. But x to the first power, using the power rule, I can say to myself, the 1 comes in front of the x. 1 minus the 1 makes 0. So anything to the 0 power is 1. So 1 times 1 is just going to be 1. So from this point on, you can just think to yourself, the derivative of any variable, if we're taking the derivative with respect to that variable, is going to be 1. And then the derivative of any constant, we just learned this a few moments ago, is 0. So you can write plus 0 if you want, or choose to write nothing. So now we go ahead and multiply. We get 24x to the second, and then 1/3 times negative 5, so that makes a positive. Negative times negative. 1/3 times 5 is positive 5/3. X to the negative 6 plus 1. So I'm going to just say y prime to tell people that is the derivative.